7 properties of limit. This property is useful when finding limit, especially for questions when it specifically told you to find limit using properties. First property is limit x approaches to a for constant, the answer will be constant. This is an example. Properties number 2 is limit x approaches to a x, the answer will be a. So for this property, you just substitute x equal to a. This is an example. Property number 3 is limit x approaches to a, x power of n is equal to a power of n. Same as the previous property, just substitute x equal to a. This is an example. Property number 4 is limit x approaches to a, c is a constant, times fx, we could write it as c times limit x approaches to a, fx. This is an example. Property number 5 is limit x approaches to a, fx plus or minus gx, we can write as limit x approaches to a, fx plus or minus limit x approaches to a, gx. For example, limit x approaches to 4, 3x squared minus x. So this 3x squared is fx and x is gx. So we can write as limit x approaches to 4, 3x squared minus limit x approaches to 4x. Just substitute x equal to 4 and we get the answer equals to 44. Property number 6 is limit x approaches to a, fx times gx. We can write it as limit x approaches to a, fx times limit x approaches to a, gx. For example, limit x approaches to 2, x cubed times x squared minus 3. So we can write it down as limit x approaches to x cubed times limit x approaches to x squared minus 3. Just substitute x equal to 2 and we got the answer equals to x. The last property is limit x approaches to a, fx over gx. We can write as limit x approaches to a, fx over limit x approaches to a, gx. For example, limit x approaches to 3, x squared over x plus 1. We can write as limit x approaches to 3, x squared over limit x approaches to 3, x plus 1. As usual, substitute x equal to 3 and we got the answer 9 of.
Hello everyone, I am Sufi and I am going to explain about the computation of limits. There are 8 methods that we are going to learn and use in order to find a limit. The first method is the direct substitution method. We only have to substitute the value of x into the function to find a limit. If we get 0 over 0 as our answer by using the direct substitution method, then we need to use the second method, which is the factorization method. There are 4 steps that we need to do. The first step is factorize, simplify, substitute, and solve. If we get 0 over 0 as our answer by using the direct substitution method, then the other method that we can use is the third method, which is the conjugation method. There are 5 steps that we need to do. The first step is conjugate, expand, simplify, substitute, and solve. The fourth method is the one-sided limit method. First, we need to know the definition of one-sided limit. Then, we need to identify whether there is a modulus or not in the function. If there is no modulus in the function, there are 3 steps that we need to do. The first step is determine, find, and solve. If there is a modulus in the function, then there are 8 steps that we need to do as shown in the slides. The fifth method is the existence of a limit method. First, we need to know the definition of existence of a limit. Then we need to identify whether a graph is given or not. If a graph is given, then there are three steps that we need to do. First step is find, compare, and conclude. If a graph is not given, then there are four steps that we need to do. The first step is draw and label, find, compare, and conclude. If we get a constant over 0 as our answer by using the direct substitution method, then we need to use the sixth method, which is the infinite limit method. First, we need to know the definition of infinite limit. Then, we need to identify whether a graph is given or not. If a graph is given, then there are three steps that we need to do. The first step is find, compare, and conclude. If a graph is not given, then there are four steps that we need to do. The first step is substitute, draw and label, determine, and solve. The seventh method is the limit at infinity for irrational function method. We only have to substitute the value of x, which is the infinity, into the function. Whenever we get a constant over infinity, then the answer or the limit must be 0. If we get infinity over infinity as our answer by using the direct substitution method, then we need to use the eighth method, which is the limit at infinity for rational function method. We need to identify whether there is a surd or not in the function. If there is no surd, then there are four steps that we need to do. The first step is divide, simplify, substitute, and solve. If there is a surd, then there are 5 steps that we need to do as shown in the slides. Let's solve from meeting.
8.2 Asymptotes. Firstly, we have the vertical asymptote. X equals to k is a vertical asymptote if limit fx when x is approaching a from the left side is equals to positive or negative infinity, or when limit fx where x is approaching a from the right side is equal to positive or negative infinity. This is the graph that shows the vertical asymptote for x equals to k. One of the steps in finding the vertical asymptote is to make sure the function is in its simplified form. A tip here is to find the value of x that causes its denominator to become 0. Now we have the horizontal asymptote. Y equals to k is a horizontal asymptote if limit fx when x is approaching infinity from the right side is equals to b, or when limit fx where x is approaching infinity from the left side is equals to b.
At point 3, continuity. Definition conditions of continuity at a point. Function that follow these three rules is continuous. Condition 1. Limit function fx, x approaches a from right side is equal to limit function fx, x approaches a from the left side is equal to L. Condition 2. Limit at function fx, x approaches a is exists, which means that it is also equal to L. Condition 3. When condition 1 and condition 2 is achieved, that means that condition 3 is also achieved, as fa is equal to L2, which means that fa is defined. Here's the graph that shows the types of continuity. There are three types: continuity from the right side, continuity from left side, and two-sided continuity. Two-sided continuity, also known as the continuity at interior point. Continuity at an endpoint. A function y equal to fx is continuous at the right endpoint a of its domain if limit function fx, x approaches a from the right side is equal to fa. A function y equal to fx is continuous at the left endpoint b of its domain if limit x approaches b from the left side is equal to fb. For continuity at an interior point, a function y equal to fx is continuous at an interior point c of its domain if limit x approaches c is equal to fc. So in conclusion, A function fx is continuous for when sketching the graph without lifting the pen, which means you draw the graph without stop, which is a continuous motion. That means the function is continuous.